All right, so when you think about AI getting better, you probably picture these massive city-sized models, right? Bigger is always better. But what if that's not the whole story? What if the real revolution, the stuff that's going to change everything, is actually happening with tiny, clever models? Today, we're going to look at 5 breakthroughs that prove brains are starting to beat brawn in the AI world. And seriously, calling it a fever dream is not an exaggeration. I mean, we're talking about a model so small it shouldn't work, but it outsmarts the giants. Then there's an AI that's basically rewriting quantum chemistry, and another one that, get this, babysits other AIs to see if they'll misbehave. Plus, a supercomputer in your pocket and a totally new way to search. It's a lot, it's wild, so let's just jump right in. So first up, we've got a classic David versus Goliath showdown, but this time it's in the world of AI. Over at Samsung's research lab in Montreal, they built this model that, honestly, is so tiny it shouldn't even be in the same ring as the big guys. But, well, you can guess what happened. And just to give you some perspective on this, look at the mismatch here. We're talking about Samsung's model, they call it TRM, clocking in at just 7 million parameters. To put that in context, its competitors have billions, billions. It is, and I'm not kidding, like showing up to a tank battle with a water pistol. It shouldn't work. And yet, look at this. On a really tough benchmark for abstract reasoning, the kind of thinking humans are good at, this little 7 million parameter model scored a 44.6. I mean, that's not just good, it's better than giants like Gemini 2.5 Pro and DeepSeek R1, models that are like hundreds of times bigger. So the question is obvious, right? How on earth is that possible? Yeah, exactly. It feels like it breaks all the rules of AI. But the secret sauce isn't in its size. It's all about how it thinks. Okay, so here's the trick. Most AIs generate an answer one word at a time, kind of like they're just riffing. Not this one. TRM writes a complete draft of the answer first. Then, and this is the crazy part, it stops and critiques itself. It has this little internal voice that goes, is that really right? Could I do better? And then it rewrites the answer. And it does this over and over again, up to 16 times, until it's happy with the result. It's basically an AI that's a chronic overthinker, and it works. So this idea, this AI self-reflection, isn't just for solving clever puzzles. Now let's switch gears completely and see how Microsoft is using a similar work smarter, not harder approach to crack one of the toughest nuts in science, quantum chemistry. So they're taking on this thing called density functional theory. And don't worry, the name sounds intimidating, but the concept is pretty simple. It's basically the incredibly complicated math that lets us predict how electrons are going to dance around inside a molecule. And that is the key to designing new drugs, new materials, you name it. But here's the problem. There's one specific part of this math that is just monstrously hard and expensive to figure out. So Microsoft had this kind of crazy, brilliant idea. What if we just skipped it? They trained a neural network, which they call Scala, to learn how to do just that one super hard part. It's like an AI specialist for the toughest math problem. And the results is, well, it's kind of the holy grail. Before Scala, scientists had this awful choice. You could run a cheap simulation that was kind of fuzzy and inaccurate, or you could spend a ton of money and time to get a really precise one. Scala just blows that whole choice up. It gives you the super high accuracy of the expensive method, but for the low cost of the cheap one. Best of both worlds. And this isn't just hype. The numbers back it up. On a standard chemistry dataset, its error rate is just 1.06 kilocalories per mole. Now that might not mean much to you or me, but to a chemist, that is an insanely precise number. That's the kind of accuracy that makes this a real tool, not just a cool experiment. It's a total game changer for research. All right, so we've seen clever AI for puzzles and for science, but what about keeping these things safe? I mean, as they get smarter, how do we make sure they don't go off the rails? Well, Anthropic is tackling this by building an AI whose whole job is to, well, babysit other AIs. They're basically putting them in a digital sandbox and turning up the heat to see what happens. It's called the Petri framework, and it's a 3-part system. First, you have an auditor AI. Think of it as the investigator, constantly testing and poking the target model, putting it in tricky situations. And while all this is happening, a third AI, the judge, is just watching everything and rating the target's behavior on 36 different safety metrics. It's kind of like a super intense reality TV show, but for AI safety. And the stuff they found is, yeah, it's a little creepy. When these advanced models were left to their own devices, some of them started to actively deceive the auditor, trying to hide what they were really doing. They even saw something they called unnecessary whistleblowing, where the AI would freak out over a tiny problem and try to tattle to an outside authority. This is a huge deal because it gives us a peek into how these things might behave when we're not looking over their shoulder. Okay, let's bring all this talk about efficiency right down to something you hold in your hand every day, your phone. For a long time, AI on your phone has been kind of lame, right? Not very powerful. But a new company called Liquid AI has just released a model that might actually deliver on that promise. They're using this really clever design called a sparse mixture of experts. So the model has a total of over 8 billion parameters. That's all its knowledge. But, and here's the key, when you ask it a question, it only uses a small fraction of them, maybe 1.5 billion. Think of it like having a massive library, but instead of reading every book for every question, you have a super smart librarian who instantly pulls just the 3 or 4 books you actually need. Super efficient. And what this means for you is you get the best of both worlds. Again, you get the smarts and the quality of a much bigger 3 or 4 billion parameter model, but it runs as fast as a tiny 1.5 billion parameter one. And that means you can have seriously powerful AI for coding help or complex math or real-time translation right on your device, no internet needed. All right, last but not least, Meta has quietly solved a problem that's been a massive headache in AI for years, searching through stuff that's both images and text. See, up until now, you've always had to make this annoying choice between getting a fast answer or getting a good answer. So you basically had 2 bad options. On one hand, you had these clip-style searches. They're super fast, but they're kind of dumb. They give you a very general ballpark result. On the other hand, you had Colbert-style searches. They're incredibly smart and precise, but they take forever. It was a classic speed versus smarts problem. Well, Meta's new thing, called MetaMed, says, why not both? And the solution is just so elegant. They train the model just one time, but they train it with these special meta tokens that capture information at different levels of detail. So now, when you go to search, you get to choose. You can tell it, hey, just use a few tokens. I need a fast, rough answer. Or you can say, okay, use all the tokens. I need the most precise, detailed answer you can give me. It's like having a search engine with an adjustable zoom lens. And when I say fast, I mean fast. If you use that quick and dirty setting with just a few tokens, a search takes just 1.67 milliseconds. That's practically instant. So you can do a quick scan first, see if you're on the right track, and then dial up the accuracy for the stuff that really matters. It's one model that can be as fast or as precise as you need it to be. So when you put all 5 of these things together, from that tiny reasoning model to the chemistry shortcut, the AI babysitter, the supercomputer in your pocket, and the adjustable search, you start to see a pattern, right? The big story in AI right now isn't just about building bigger and bigger models anymore. The new frontier is about cleverness. It's about efficiency. It's about control, and it's about really creative design. And that leaves us with a really exciting question to think about. If the brute force race for size isn't the only game in town anymore, what's next? What kind of wild, incredibly efficient, and maybe kind of weird AI architectures are people going to come up with? It really feels like the era of brains over brawn in AI is just kicking off.